Hello, friends, students, and enthusiasts. Welcome back once again. So, I have come up with a new project, very simple project, basic electronic project where no codes, no microcontroller for your learning purpose. Name of the project is Smart Traffic Light with Emergency Vehicle Override, right? Will override. That is, you can see traffic light. If suppose the traffic is stuck there and some emergency vehicle is there, like ambulance and all, and they can override by themselves the traffic light and they can pass because it is an emergency. Okay, so this particular project is divided into three parts. What are those three parts? So first part is we are used a IC that is called as timer IC, that is any 555 timer IC. In this timer IC, we have set the timer in your a stable clock mode, a stable clock mode. To adjust the timer and working of traffic light pulse, it can be adjusted with the help of a preset. Okay, I have used a preset also. I will show you here. You can see on the main, there are two part of it. The one is traffic light and this thing. I have shown only two lanes here. Okay, you can add 4 lanes or more than that. Accordingly, you can add it up. Okay, so first part is your timer IC for generating pulse. Second is the sequential divider. That is, we have used an IC that is called as CD4017, which works like a sequential divider. Okay, that means Q0 to Q5 we are using here. Q6 is also there, but we are using only 5 up to this 5 or 6 here. Okay, use for lane traffic light control. Simple. Whatever project, a simple project you want to do it about traffic light, this is the IC which you have to use. That is a lane traffic light control with the help of a some transistor. Suppose you are using more number of transistor at that time, what you will do, you will use a separate transistor for this. Okay, right. So what is the project idea? Normal traffic light, sequentially green, yellow, red. That is the normal one for two direction when an emergency vehicle is arriving. We are showing it for two direction. IR beacon or dedicated push button. That there are two. This thing is there. IR as well as push button. That I will explain when we go to the lab. Okay. Give to the emergency lane and hold it until cleared. Okay. It will be giving way to the ambulance and this thing. Okay. Right. So components used 555 IC1, CD4017, 1358, that is operational ampere, or one comparator only I have used here. LEDs 6, you can use more than that. You can use it in series also. You can, if you want more LEDs, high brightness or low brightness, it's up to you. Right, 6 transistor I have used here. I have written 2N222, but I have used BC547 transistor as a LED driver. Those all of them are NPN transistor. We can use our MOSFETs also. One IR receiver module, TSOP module, any of the module you can use it. Push button manual override. That is one push button I have used it here. Register, few of the resistor 220 ohms and all. And for timer, we need different resistor R1, R1, R2, and C1, C2. This is C1, C2. I've used 10 microfarad, R1, R2. R2, I have made it as a like a variable type, and one is fixed one. Okay, so I have given all the values in the schematic diagram. This is a very rough schematic diagram. I'm specially made for this because this complete project, what I was looking, it was not there anywhere in this thing. So I have made this complete this thing. So you, from looking into the diagram, you can just go for it. Okay, the only traffic light projects are there in the market. Okay, it is there in the web, but overriding with the help of this, that is switch as well as the IR, it is not there. So we have added into this. So you can see in the schematic diagram here, one is, this is the first part, this is the second part, and this is the third part. Okay, and this is your complete drivers for the LEDs: green, yellow, red, green, yellow, red. Okay, so TSOP, that is the IRS. We are in our lab as we are discussing about our project, that is new project. Simple electronic project, that is smart traffic light with emergency vehicle override. All right, so I will just explain you what are the parts, how it is working. So one side of the board, this side of the board, that is I have made it. So I will just explain you about this. So there are three parts I said already we have discussed. So first part, this IC, that is timer IC. The second part is the decade counter, that is 4017 IC, and this is our operational amplifier LM35358. Okay, and this is my IR sensor. Okay. So how it is working, I will go to this part little later, but this how. So timer, you can say more stable, a stable multi-vibrator timer. You can see the light, the red color light is blinking. We can adjust according, we can adjust the timing according to this preset I have given here, 200K. All right, this regulator in between is for 5 volt. I've just kept it in between because the whole circuit is powered by 5 volt regulator. Okay, the input I've given it from the adapter, that is 9 volt adapter, and this is the output. Whole thing is working with 5 volt. So this IC is working with 5 volt. Okay, this is my a stable multi vibrator. We are finding the pulse over here. The same pulse. This from here I have taken. I have given it to from pin number 3 as an output that you can see at this blue wire. So this I have given it to pin number 14 of the second stage, that is decade counter 4017. Okay, that is the input to the counter. Now output, that is from this IC, that is it is a 16 pin IC. Pin number 16 is supply, pin number 8 is ground, pin number 15 and pin number 13. These two pins are very important for us, 15 and 13, that we have connected to the reset. Okay, so to reset means what? I will just tell you a little later. Through a diode, that is iron 4148 diode. There are two diodes over here, you can see. Down here I have given it to pin number 15 and pin number 13. Okay, so why it is given, that we will see later. So right now there is no override. That means there is no, this particular stage is not working. That is operational amplifier is not working. When operational amplifier will work, when there will be a signal on the TSOP, that is the IR sensor, as well as a switch. Suppose if I operate the switch or this, then only this override will take place. That will, it will stop the regular working of the traffic light, and it will override. That means once it will become green, all the lights will be closed, and that particular area or that particular road will become green. Okay, that is the idea. That is the meaning of override. Okay, so here also we have used only one operational amplifier, that is pin number 1, 2. Sorry, pin number 1 is output, pin number 2 and pin number 3 are the input. One is negative, one is positive, which has been given to resistors, that is a voltage divider preset, and one is coming from the TSOP. So likewise it is working. Pin number 1, pin number, your switch is connected to, one end is connected to 5 volts, another end is connected to uh, your pin number, it is going to, through this line, it is going to pin number your 3. Okay, the same thing, TSOP is also going to 3. This pin is also going to. That means when I press this, or when there is activity in this, activity automatically it will overwrite. Overwrite in a sense, the traffic light will, the regular working will stop, and only one lane, either A or either B. I've shown two lanes here. So either A or either B will become green. That is that thing. Okay. So with the help of a remote, as well as there is a manual button over here. Okay. So these are the three stages, 1, 2, and 3. Okay. This stage, that is the final stage, operational amplifier stage, is only for overriding. This is the regular traffic light signal for functioning with the help of the pulse, that is the tiny pulse which is given from here to pin number 14, how it will work. All right. So I will just show you how the regular light is working now. All right. So you can see this circuit now. I have just zoomed it to this particular circuit. This is my traffic light management board. I have given it separately because it was just jumbling around. So I have put it on a separate this thing. I will explain you about this. So I have taken right now two lanes, lane number A and lane number B. So these three lights on the top for lane number A and these three lights for lane number B. Okay. So now the things are working normally. Normally in a sense that the regular traffic light is going on. That means the one side will stop A and B. According to that, it is going on according to the pulse which is coming from here. Right. Okay. And for CD407 is giving you the output. Now, how many connections are there and how many transistors are there? I have used only one bulb here, that is red, green, and yellow. Red, green, and yellow, two strands. So I have used a separate transistor, NPN transistor, BC547. Any transistor you can use, 6 transistor for driving 6 LEDs. Okay, right? 3 for one lane and 3 for another lane. So our total connections are 1, 2, 3, 4, 5, 6. So 6 connection. From where it is coming? Those 6 connection. Those 6 connection are coming from your CD4017. I will tell you what are the points. So pin number 1, pin number 2, pin number 3, pin number 4, and pin number 10. Right? So these are the main connections. Okay. All these connections are coming from CD4017. Okay, that point, that's the normal traffic light. You can check any of the circuits, it is same only normal traffic light. Only the thing which I have added here is overriding. That is, I have used an operational amplifier, that is LM358, to override this problem. Okay, so normal traffic light is working. Now I will show you how we can stop it or how the override works. All right, friends. So I've just turned it around because there is a jumble of wires and all. So I will be sharing, I've already shared the schematic diagram. It's a very simple circuit with a little advantage, that is overriding. Okay. So I will just explain you. Now the traffic light is working as usual. That is normal. Okay. Now suppose if this TSOP receives a message, that is some ambulance comes and the driver or the subordinate has a remote with him, and he will just show this remote, or he will just put towards this thing and presses the button, right? So you can see here, see, yeah, it has become green. Okay, so everything stops, all the light stops here and it will become green. Watch it once again, right? It has become green, all the lights have stopped. Okay, so this is one part, that is through remote control. Using this IR, he is controlling or overriding the complete thing. The second part is, if suppose he doesn't have a remote, so there is a switch also which everybody doesn't know, and he can just press the switch also. Like with the helping of the switch, he will override. Okay, so both the way, that means two ways, with the help of a remote and with the help of a switch, he can override. And as soon as he passes, for some, after some time, the timer is over and the automatic system starts again. This is the smartest way, that is smart traffic light emergency system. So it's a new project, very good project. Students who want to do it, the beginners who want to learn, and they can do this project. So this is normally now it is on the normal position. So it works on 5 volts. Please remember, it works on 5 volt. I will use a 5 volt regulator. You can use it with 9 volts also. Please remember, don't put more than 9 volts to the system. Okay? This TSOP works only with 5 volt, and this IC you can use 9 volts, of course. And of course, here you can go up to 12 volts, or depending upon the number of LEDs you are using for the real this thing, that is, you can take the voltage according, or separate voltage for this particular board, that is for driving the LEDs. Okay, I hope you understood this. I will share the I have already shared the schematic diagram. Please try and let me know if you have any difficulties, or if you, please suggest me what type of projects you want. Okay, right. So thank you very much for watching.